there is some interesting new findings that I've been doing, mostly the work of Iris Beren at Northeastern University. She's an Israeli-American psycholinguist and psychologist. And we wanted to know, when people talk about dyslexics have problems with phonology, we wanted to know, well, what kind of problem with phonology do they have? Is it high level, like phonological grammar, like the kind of thing about knowing when to use and how to use sound combinations that are legal in a particular language? Or is it lower level, having to do the phonetics, just parsing that sound stream into sounds that are meaningful to that language? One is more brainstem, maybe thalamus, and the other one is cortex. Again, trying to prove the point that this is a very early abnormality. And when we did one study, and I give you some clue about the study, when we presented Israeli Hebrew speakers with pseudo words that had a consonant repeated in the first syllable and a consonant repeated in the second syllable. Both of them are meaningless words. And they had to decide whether this is a word or not a word. So you hear a pseudo word and you're asked, is this a real word? Press this. If it's not a real word, press that. And we analyze the time it takes them to decide and how many errors they make. And it turns out that you would recognize an illegal word as being a non-word faster than a legal word. Because the legal word sounds like it could be a word. Maybe I don't know the meaning of it, I've never heard it before, but it could be a word, so you sort of, it's a legal word, so it take a little more time. The illegal word, because it's repeating the consonant in the first syllable, you immediately know it couldn't be a word, so you're much faster in it. So we wanted to know if dyslexics know anything about phonological grammar. And they do. They're not as good. They're not as good. They make more errors, and they're slower than non-dyslexics, But they can tell the difference between legal and illegal words, which means that the cortex is working probably fine. It doesn't get good information from below, but to the extent that it gets information, it's doing okay. They have problems with speech perception and speech discrimination, and that's been known for a long time now. That means they can't tell one sound from the other. They're not hearing it quite right. They don't have the strong, robust representation of these sounds. And so they do much worse with speech discrimination. And in fact, sometimes they have trouble discriminating speech from machine speech. They really are quite bad at speech discrimination when they're young. Okay, so with this kind of an experiment, we are showing that even the phonological problem they have is of a low level kind, the kind that's being processed in the brainstem and the thalamus, and not the kind that is being processed in the cortex. That doesn't surprise me. If they had trouble with grammar, I think they would be stupid, because grammar is what determines that we're human. That's what we do. Grammar in everything. Grammar is the ability to take a small number of elements, combine them in different ways to get different meanings. We do that with vision, we do that with memory, we do that with language, and it makes us real powerful machines. Grammar is human. We have no evidence that any animal other than humans have grammar. Okay? I don't think you could have a problem with grammar and be quite human. And we know very well that dyslexics can be just as bright as anybody else. This didn't surprise me. It doesn't surprise me that the kind of phonological problem that dyslexics have is a very low level one having to do with sound processing, which affects speech discrimination and affects representation of sounds, and nothing more cognitive than that. We did another experiment in which we were looking at sonority. There are certain kinds of combinations of sounds that are more acceptable than others, like a low sonority sound followed by a high sonority sound. It's more usual in a language than the other way around. So it's much more common to have a combination of BR, for instance, a burr. The B is not really sonorous. You just close your lip. And what really sounds is the R. Burr. That lasts for a long time. But herb, that is very uncommon in a language. And all languages have sonority-related rules. All languages tolerate low sonority and high sonority combinations more than the opposite. You can study them in any language. And dyslexics are just the same as anybody else. They like the sonority combinations that everybody else likes. Again, showing their phonological grammar is normal. So no, what I'm trying to say now is that even though my research started focused on the cortex, because this is what we knew, the cortex is involved in reading, it's involved in thinking, it's involved in all the things. As we did more and more research and we focused more and more on development and the younger ones and the early learning paradigms for children to acquire sound structures, we have moved away from the cortex and more into subcortical structure. What could this mean? In a dream world, it could mean that you could put a hearing aid in a baby at risk that transforms sounds and makes them more possible for that baby to represent the sounds of the language. It's an engineering challenge, but it's a possible thing to do. If they had a cortical problem, you couldn't put a hearing aid in there. You would have to have a neurosurgeon go in there, and you don't want a neurosurgeon going in there, right? So this would be a very non-invasive kind of thing to do, put a hearing aid up. Imagine if you can combine noisy neuron suppression with a little hearing aid. You have students in your class now who you can teach them, because they're not going to be perfect. But you have a lot of students, and no matter what you do, they're still not having a great deal of difficulty learning. There are others who are able to learn more. I think the ones who can sort of move on to sort of executive approaches to guessing and using a lot of other information, multisensory information to help them along, those children are going to do better. But there are others who can't do that because they don't have those kinds of, skills. And there will be children that might be helped by this. And we're not there yet. I'm just hoping to look at the future and seeing this kind of improvement.